All right. So let's just start with why Kafka. What is it? Why should you even care about it? Well, Kafka really comes down to something called microservices, right? So microservices is essentially when you take a big monolithic application and you break it up into a handful of other processes so you can pick up discrete business logic functions like, let's say, maybe logging or user authentication to handle a very specific thing. And you can put this into its own application, and those different microservices can communicate since they're going to need to do that and almost always done via HTTP. So you basically have all these independent things that coordinate smartly. And it is really in demand when we're talking about it. So basically, microservices and monolithic architectures are two fundamentally different things. On the left-hand side, you see monolithic. On the right-hand side, you see yes, I'll put my email in the chat box here. There you go. So basically, a microservice architecture. So in a monolithic architecture, you basically interact with what's called the three-tier architecture, where you have the UI layer that the user interacts with, where they click stuff, and which happens to trigger functions inside your business logic layer, which is then used to access your data access layer to communicate to a single database, and that stores all of the data and the business logic into this giant beast that has everything. Microservices, you still have one user interface that the user interacts with, but these actually trigger independent microservices, which could have a shared database, or maybe they could each have their own database, and they all have their own specific function. So let's discuss the advantages of microservices. So microservices provide fast value delivery. What means is that we can fix the component of the microservices easier if we know we can release it and run it independently of everything else. We can implement new features faster because you can just put it in one component and it doesn't have to affect the rest of the topology. Now we can run experiments like all of a sudden we want new features and we want to validate assumptions faster. That's super valuable and that allows businesses to grow because we're basically moving from, like, let's say, a centralized process to a distributed process. And the other benefit of this is since you're working on a microservices topology, you're only changing pieces of the puzzle rather than fixing every single component in the bigger puzzle. And that is basically kind of allows us to have teams that are focused on just the microservice. So microservices are language independent because these microservices communicate via HTTP, and it doesn't matter what is happening on the back end as long as they conform to HTTP standards. So they can communicate from one microservice, which is written in Java, to another, which is written in Python. It really doesn't matter. Another advantage is it allows you to actually split up each microservice into its own team. So in a monolithic architecture, you would have, let's say 30 people working on a giant project with a waterfall paradigm. It's big, it's clunky, it gets complex. On the other hand, in microservices architecture, you can put maybe 3-4 people on each microservice, and they are responsible for specifically that microservice and everything that it does. They can pick up the iteration cycle that works for them. They can pick the language that works for them, and it lets them work really fast and easily on very specific functions. So microservices also isolate faults, exceptions inside your app program. So if one microservice fails, it doesn't necessarily mean that the entire application fails, especially if you're practicing a RESTful APIs. So RESTful APIs in one microservice can handle another microservice's failure and respond accordingly to the user through the user interface. It doesn't have to essentially just crash the entire system. So microservices work well with containers, and you can containerize a single microservice, which makes everything scalable. Now, this really is one of the biggest advantages to microservices that are dynamically scalable at runtime. You know, when using the you can you don't really split partitions. You'll look at a slide of the copies. All right. Back pressure, just spin up more consumers, honestly. That's kind of the best way to handle back pressure. So if you need to, you can add more partitions. Another way really to handle better back pressure is to add more brokers to the cluster. So more partitions first. Then if that's not helping, it'll be pretty obvious when it's not helping, then add more brokers. But don't add like, you know, an exponential number of partitions. Add like one. You can't really manage partitions through an API. Well, actually you can. So you can add partitions to a cluster. You can't really delete partitions. Yeah. So let's talk about how you do problem solving with Kafka. Very, very quick thing here. So think of the input, think of the output. And let's say I wanted to determine what Trump's travels and mood plans look like. Well, think of the input. Where can I find Trump's travel plans? Where can I find his mood? Twitter. Pretty obvious, it's Twitter. So I think what I would need to do here is I'd pull the Twitter data by writing a Kafka Twitter producer. So this Twitter data will be pulled from a Twitter Kafka producer and feed into a Twitter topic. And we will use the tweet location as a partitioning key. So all the records are going to one partition, which match a certain location. So we're keying on location. Then we do the Twitter topic. So we basically pull data from the Twitter topic. We perform a sentiment analysis on it with our Kafka consumer. In each sentiment, we partition based on location. So if he's happy in New York, put the happy into the New York key. And then we pull from the mood topic and we actually average all the results to perform some aggregation. This could be a streaming model. So essentially, when you're building a Kafka data pipeline, you just want to think of like, what does your model look like? Where's the data going to go, etc. Okay. Size limit to the number of messages. Generally, you should keep your messages under 10 kilobytes. If you do any higher than 10 kilobytes, just going to delete this item. Okay. Now you'll be able to run this exercise in your own laptops. I'll send that after the instructions. So I'm going to write a very simple consumer. So I'm going to run my failover producer. Okay. So the producer is running. Now I'm going to turn on my consumer, which will be running here. Yep, so the consumer is running. So we have just one consumer running, right? Now keep in mind, they're not a consumer group. So watch what happens at the bottom right-hand window. 1, 2, 3. Okay. So they're getting the messages. Pretty neat, huh? What do you think happens when I switch on another consumer? Remember, they're not in a consumer group. One, two, three, 4, 5, 6, 7, 8, 9. Why does this message? In fact, I'm going to turn on another one. Just for good measure. 1, 2, 3. Interesting, right? So in this case, each of them are getting the same message. It's being copied multiple times. Why do you think that's happening? I can explain it to you fairly simply. Because they're not working in a consumer group. So if I wanted to have them share the load, the workload, this is when I would okay. Okay. Sorry, I'm just setting up my windows so you can see what's about to happen. So here you go. So now we've assigned them all a consumer group, right? So theoretically, since they're acting in a group, they should be able to be like this. Okay, cool. Oh, the link to the tutorial. Yeah, I'll just copy and paste it. Jesse, can you just put your email ID in again? Sorry, I'm trying to keep on top of everything. You know, you guys can just scroll up if you're trying to find anything, okay? Okay, Asif, I need your email ID and your cluster ID. I haven't sent the email yet with the deferred clusters. Okay. Okay. Thank you, Jess. Okay. Okay. Okay, we have a lot of cluster ID. Okay, just give me a second. I haven't raised the ticket yet. Okay, just putting together one list. Okay, another cluster ID. Asif, I need your email ID. Thank you, Asif. I know you've typed it before. It's just I have so many windows and so many messages in the chat work. Wait, I'm so confused, Asif. You have two emails? Okay. Oh, there are two Asifs. There are two Asifs. I'm sorry, guys. I'm really sorry. Name collision. Oh, that's so funny. Okay. All right. Yeah, okay. I just sent out the cluster IDs. So it should be good now. All right, so my team's working on it. Just be patient. Things will start turning on for you. In the meantime, you know, we can just talk about anything. We're all friends now. So, how's the weather in your part of the world? I'm in Arizona. It's really hot, and that's pretty awesome. And they've also lifted all the restrictions here, so I was able to get a haircut and all that fun things.